off we go with the answers to the simultaneous equations problems. So question 1, we've got 2 pens and 3 pencils, and they cost £1.35, and we've got 5 pens and 2 pencils, cost £2.55. Now, the way I go about these is I'm looking here and I'm seeing, well, I've got 2 pens and 3 pencils and 5 pens and 2 pencils, and the pens are different and the pencils are different, but I know that 2 and 5 both go into 10, so if I multiplied the top by 5, then that would give me 10 pens and 15 pencils, and it would cost me £1.35 multiplied by 5, which is £6.75. Okay, now the bottom row, if I double that order of stuff, say, then I've got 10 pens and 4 pencils, so I'm doubling it, and £2.55 doubled gives you £5 and 10 pence. Okay, so this is useful, and the reason it's useful is because I've got 10 pens in both of these orders, and that means that the reason this cost more money, the £6.75, is because of more pencils. So let's see, we've got 11 more pencils, and the extra cost, well, that's £6.75 take away £5.10, which leaves you with £1.65. And if I divide that by 11, then I get 15 pence. So that's 1 pencil costs 15 pence. And now I've found out what a pencil can cost, I can use either of these to work out the cost of a pen. So I'm going to use the bottom one. So 5 pens and 2 pencils, so that's 2 times 15p, costs £2.55. So that's 5 pence and 30p there. So if I take away the 30p from this, I'm left with £2.25, aren't I? And that must be the cost of the 5 pens. So if I divide that by 5, so £2.25 divided by 5, then I will get the cost of a pen. So a pen costs 45 pence. And that's the other solution. If that went a bit fast for you, just hit pause, rewind it, and have a look through and see if you can follow that. The key bit really is getting the number of pens the same and then looking for the difference. And now that we come on to something like this, well, that's what we're going to do. So let's have a look. We've got our x's and our y's and our numbers. So we don't have pens and pencils, we have x's and y's. And we don't have cost, we've got a number. And when I'm looking at this, I'm noticing that there are 2 x's there, but only 1 x there. So I would like them to be the same. So I'm going to double the bottom one. Now some of you are saying, well, the y's are the same, why doesn't he use them? And I could. So that's the top. Now the bottom one doubled is 2y minus, 2x even, 2x minus 6y, and I've got to double this as well, so it's 18. Now, the difference between the top and the bottom is that the bottom one has got less y's. Okay, so I'm going to treat this as a subtract, and I'm going to do the top take away the bottom. So 3 minus 6 is 9y. Because I've got 3 and I'm minusing -6. And on this side, 0 minus 18, well, it's minus 18, which means that y must be -2, because 9 times -2 is -18. And that's my first of my answers. And now I'm going to substitute back. And and I'm going to call these 1 and 2, and I'm going to substitute into 1. So I've got 2x plus 3 times y, and y is minus 2, equals 0. So that's 2x, 3 minus 2s are minus 6. So add the x 6 across, so I've got 2x equals 6. Why? Because 6 minus 6 is 0. So x must equal 3. And that's my second solution. And we've got the same thing here. No more difficult really. Let's just do it again. Bit of practice. We've got a choice here. We could go for the x's or the y's. I'll go for the y's this time because there is a bit of a complication that could arise from them. So 3x, I've got 4 and 2, so I'm going to leave the top one as it is. So 3x add 4y equals 7, and I'm going to double the bottom one. So 10x minus 4y equals 32. Now, the difference here is that these aren't the same. They look the same, but this one's a minus 4 and this one's a plus 4. And they're totally different numbers. Imagine the number line, they're in different places. So I have to deal with this slightly differently. Now, if I subtracted, I would have 4, positive 4, minus 4, which would give me 8. And so I'd have 8 y's. And that wouldn't have got rid of the y's. So I need to add. Just to stay on that for a little bit longer, if we just look back at the last ones, by making the two x's the same, we could effectively ignore them really. And the same thing at the top, by making the pens the same, we could ignore them and look for the difference in the pencils. Now, down here, we've made them both 4, but they're not the same. So anyway, let's go and carry on with adding. So 3x add 10x is 13x, plus 4y plus minus 4y is no y's, and that's the point of this exercise. And then 7 plus 32 is 39. And that's a good sign if you know your 13 times table, because 13 times 3 is 39, and that's our first answer. And now we're going to pick one of these. I'm going to go for the top one. So substitute into 1. So I'm going to do 3 times x, but x is 3, so it's 3 times 3, plus 4 times y equals 7. So 3 times 3 is 9. 9 plus 4y equals 7, and people start thinking, it's not possible. Well, it is. It's a negative answer, isn't it? Subtract 9 from both sides. 4y is equal to 7. Take 9, which is minus 2. Let's go over here now. So divide by 4. Minus 2 divided by 4, which is minus a half. So y equals minus a half. That's our second part. Now the challenge question. So this is right on the difficult end of things. So we've got a quadratic here. Notice the powers of x. In fact, for those of you that are well prepared, this is the equation of a circle. And the way we solve these is we take our line, this is a straight line, and we need to turn that into x squared or y squared. So if y equals 3x plus 1, y squared must equal 3x plus 1 squared. And here is a possible mistake. A lot of people square the 3x and get 9x squared, and they square the 1, but they forget that actually you've got double brackets here. And when you multiply them out, you will get 4 things that will turn into 3 most of the time. So 3x times 3x is 9x squared, 3x times 1 is 3x, and another 3x, and a 1. So it's 9x squared plus 6x plus 1. And that's what this is. And now I can substitute. So I'm going to substitute into x squared plus y squared equals 5. Here we go. So we've got the x squared. Now y squared is this lot, so it's plus 9x squared plus 6x plus 1 equals 5. And I'm going to simplify it, so I'm going to add those two together to get 10x squared plus 6x plus 1, and I'm going to subtract the 5 to leave it equal to 0, and you'll see why in a minute. So 10x squared plus 6x. 1 minus 5 is minus 4. And you can see this is a quadratic, and I'm going to factorise it, but before I factorise it I'm going to check to see if there's anything I can do to simplify, and actually I can. All of these are even numbers, so I'm going to halve them all. I'm going to divide through by 2. And that's going to make the factorising a lot easier. Now, I don't have much choice. 5 has got to be 5 and 1 because 5 is a prime number. And 2 has got to be 1 and 2. So I need to make a 3x. So I can either go 1 here and 2 there, or 2 here and 1 there. And I'm just going to make that decision now. I'm trying to make 3. So if I do 5 times 2, that will give me 10. That doesn't look good, that doesn't. So 5 times 1 and 2. So I think the 2 goes here, and the 1 goes there. Now I want a positive 3, so that's going to be positive and that's negative. Now for those of you who find that a bit of a mystery, there is actually a method you can learn. So if you're concerned about this, come and see me and I'll show you the method for doing this. It always works, you don't have to guess. But what I would say is don't sit there and try and work it out in your head. There'll come the point where you've had a good think about it. Try one of the options and do what I'm about to do, which is multiply it out to check. So 5x minus 2 x plus 1, I'm just going to check, so that's 5x squared, that's good. That's plus 5x, that's minus 2x, and then minus 2 times 1 is minus 2, and so that simplifies to plus 3x minus 2, which is of course what I wanted. So do that, and there's nothing wrong with spending a few bit of time guessing. Now, to solve it, find x, so x is either going to be, so either we've got the first bracket, 5x minus 2 equals 0, which means that 5x is equal to 2 and x is equal to 2/5, or x plus 1 equals 0, which means that x is equal to minus 1. So those are our two x values, and this is a point at which it's very easy to forget that you're dealing with an equation that's got y as well in it, so we need some y values, and I would strongly recommend you use the linear equation for this. So y equals 3x plus 1. So let's go for that. So y is equal to 3 times 2/5 plus 1, because y equals 3x plus 1 and x is 2/5. So y is equal to, now 3 times 2/5 is 6/5. 1 is 5/5, so that means y must equal 11/5. So y equals 11/5. And over here, when x equals minus 1, y is equal to 3 times minus 1 plus 1, which is 3 minus 1, so y equals 2. So we've got two pairs. We've got this pair here, and we've got this pair here. And don't forget to get your x's and your y's. And there we go.